Okay, today I'm going to show you how to name and write formulas for binary ionic compounds. And we're going to first deal with metals that we know the charge of, which are called group A metals. And again, the group A metals are the ones that we know the charge of are those in column 1, those in column 2. Because group A are actually the first 2 columns and then the last 6. These are called group B here. They're also called the transition metals. And because they can have more than one charge, when we name them and write formulas for them, we have to deal with them a bit differently. So we're going to deal with both those today. So first of all, we're talking about things that are group A, binary compounds. So column 1 is +1, column 2 is +2. We also know aluminum, zinc, silver, and cadmium. Aluminum +3. Zinc and cadmium +2, silver's +1. Again, it's something in the past we'd have people memorize, but this is a source for you, so you won't have to remember those, so write them down. All right, so let me show you first of all how to write formulas for a binary ionic compound. Now, it's helpful to understand terminology. Binary just means 2 things. That's what binary. Ionic compounds are actually compounds between, so an ionic compound, over here on this side of the zigzag line, these are metals. And over here, these are nonmetals. And the combination of a metal and a nonmetal makes an ionic compound. And so binary ionic compounds, what we're doing today. And when you list a metal combining with a nonmetal, you always list the metal first. The thing furthest to the left goes first. It's not just random how you do these. So first thing we're looking at is how to write a formula for the combination of calcium and bromine. And again, so what we'll do, move that up there, see the table, is the first thing you need to do is write down the symbols for the elements. We got that over there. Calcium's charge is +2. Write the charge above it. You don't have to put plus or minus because this is not a math problem. What I'm just showing you how to do is to write the correct formula for how those 2 elements will actually combine with each other. And then bromine and its charge, bromine is right here. Notice the -1 goes with column 7, not that these are 0 here. So it's -1. And then all you have to do, so once you write the charges for the elements above them as a superscript, the next thing you do is decide whether or not you can simplify those numbers. 2 and a 1 cannot be simplified. The 1 can't be simplified. And then all you have to do is cross the charges, and you will now have the formula. The 2 goes here, the 1 goes there. 1s are understood when you're writing formulas. There is the compound for calcium and bromine. And I think it's helpful to understand like why that works. Because you're just, in a binary ionic compound, you're just going to take the charges and cross them every time. It's a very simple thing to do. But you need to understand why that works. And let me show you real quick why it works with a dot structure. And we will revisit this later in the year. A dot structure just show the valence electrons for an element. And you use dots to show how many valence electrons they have. Now calcium is in column 2. So I'm going to put 2 dots there. It's got 2 valence electrons. Here comes the bromine atom. And bromine's in column 7. So I'm going to put 7 dots around it because it's got 7 valence electrons. So again, calcium, what it does is it gives one of its electrons to that bromine, but now the bromine is now -1, and it's got an extra electron, but it's full. So the calcium still has an electron to give away. Here comes another bromine. Again, they start off with 7 valence electrons. Calcium gives another electron to another bromine. It's now -1. Calcium lost 2 electrons. It was +2. Notice that was the charge. A bromine gains 1 electron in a compound. That's why we put -1 there. And that's why they go together the way they do. Calcium had 2 electrons to give away, but each bromine can only take 1. And that's why the formula is 1 calcium for 2 bromines. Again, like I say, we will do this later in the year to make sure you totally understand this. It really helps to put this stuff together like this. But for now, you just have to cross the charges and put these together. So let's quickly go through these. Barium is +2. Again, it is in column 2 on the periodic table. Try to put the periodic table there so you can see it a bit. And so here we go. So barium is in column 2, so it's +2. Sulfur is in column 6, it's -2. And but remember, if you can simplify the charges, now again, I don't like the pluses and minuses here because it's not a math problem. You don't have to put plus. Metals are always going to be positively charged, and non-metals are going to be negatively charged because metals are always losing electrons, non-metals are always gaining them. That's why they always have to be plus and minus. But if you can simplify the charges, you simplify them before you cross them. You simplify those, again, you end up with just BAS there. In this case, again, we can't simplify those. All you got to do is cross the charges there, be Li2O. We just took the 2 and put it there and the 1 there. That's all you have to do. Again, we've got to cross the charges once we've established what they are. Calcium, again, is in column 2 on the periodic table. Nitrogen's in column 5, which are -3. So there's nitrogen there. And again, just cross them. You end up with a 3 there and a 2 there. So Ca3, N2, copper. I gave you the charge for it because it could have more than one charge. But again, cross them. You end up with CuI2. All right, moving on to do some more just when you have the names there. And so it says copper 2 sulfide. And so copper 2 sulfide, the 2 is representing copper's transition metal. That's how you have to represent its charge. So that's what the 2 actually means for copper. And I'll talk more about that in a minute. So copper's charge is +2. Sulfide, when it says sulfide, the way you name any binary ionic compound is just write the name of the first element and change the ending of the nonmetal, the second element, to IDE. So change it from sulfur to sulfide, and now you have the name. Like the combination of sodium and chlorine is not called, or Na and Cl is not called sodium chlorine, it's sodium chloride. We just changed the ending of the last element to IDE. So we're talking about the combination of copper and sulfur. Sulfur's charge, you can look it up on the periodic table, is 2 as well. Remember, y'all, all you have to do before you cross them is decide whether or not you can simplify them. You can simplify those to 1. That compound is CuS. All right, moving on to the next one there, potassium nitride. Find potassium there on the periodic table. Its charge is 1. Nitride means you're looking up nitrogen. That's how you change the ending to, the non-metal in the compound. Its charge is 3. Again, you can't simplify those. Cross them. K3N. All right, next one, sodium iodide. Again, sodium, Na, +1. Sodium's right there on the periodic table. Iodine's in column 7, down there. It's -1, so I shouldn't put a plus there. It's just 1, and iodine is 1 as well. Cross them. There's nothing to do there. NaI. Potassium sulfide. So again, there's potassium in column 1. It's 1. Sulfur, again, so sulfide is talking about sulfur, and then sulfur's right there in column 2. It's -2. Pluses and minuses, again, don't matter. Remember what I said earlier, the metals are always positively charged, non-metals negatively charged, and just cross them. K2S is how you put those together. Last one there, magnesium oxide. There's magnesium. It is +2. Oxide is referring to oxygen, so there's oxygen there. It's -2. So they're 2 and 2. Can you simplify those? Certainly you can. You can make them into 1 and 1, and then you end up with MgO. And I'll show you with the dot structure why that works that way, because we'll put 2 dots for magnesium. That represents its 2 valence electrons. It's in column 2. And then oxygen is in column 6. So it has 6 valence electrons, and the reason they go together in a 1-to-1 ratio is because this one magnesium can give its 2 electrons. Now it's +2. Oxygen's now -2. But if you look at the actual compound, it is just 1 magnesium and 1 oxygen combined together. Again, you can do the rest of these on your own here, and the answers are all at the back, so that you can always check your work to make sure you know what you're doing. When you're writing formulas for these compounds, for binary ionic compounds with transition metals first, remember the transition metals are those in the middle part of the table. they can have more than one charge. So they're giving you, they always have to give you a Roman numeral to give you the number of electron or the charge of that particular transition metal, because you can't look here and go, I know the charge of copper for sure because it's in a transition metal. So that's what the 2 means. It means the charge of copper is 2. The nonmetals, we know the charges of all of those. They're referring to sulfur there with the sulfide name. And so there you go. So they're both 2. Remember, we can simplify them. You end up with CuS. Iron 3 oxide. Again, why does iron have 3 charge? We have no idea what its charge would be. That's why they're telling us what it is, because iron can actually be +2 or +3. So you just write the charge of it above it. It's referring to oxygen there. It is in column 6. Its charge is 2. Again, cross them. Put the 2 there, the 3 there. Fe2O3. It is that simple. The people that struggle with this the most overthink it, and again, they think it's some type of math problem, but we're only showing you how these particular elements go together in a compound. What this means is 2 irons, that's 2 Fe's, combined with 3 oxygens to make that particular compound, iron 3 oxide. All right, 10,4 sulfide. So that's telling us the charge of 10. In this case, it is in column 4, and it is +4, but it's not always +4. They're telling you that it's +4 in this case. And then sulfur, it's 2. But remember, if you can simplify those numbers before you cross them, you do that. You can simplify those to 2 and then 1, then cross them. The 2 goes there, the 1 goes there. So that's SnS2. And let's see, the next one, cobalt 2 nitride. Cobalt's charge, again, you're getting the 2 because there's cobalt. All these would need a Roman numeral when you're naming them because we don't know what their charge is. We got to know that. So cobalt, they're telling you it's 2. Nitride is referring to nitrogen. And so there's nitrogen. Its charge is 3. Cross them, CO3N2. That's it for this lesson. Good luck doing the practice.